Sangpo. Welcome to Bhutan e-learning project. This is a physics lesson for Key Stage 4, classes 9 and 10. My name is Funsu Chodin, and in today's lesson, we will learn 4 concepts in physics: speed, velocity, acceleration, and terminal velocity. Before I start my lesson, I want you all to look at this table. So this table has differences between distance and displacement, and among many differences, these are the 3 most important differences between distance and displacement. So I would like you all to keep this in mind. And now let's look at the first concept. So for that, I want you all to read this sentence and understand it. Okay, now in this sentence, there's one very important point. Can you guess which one is it? Alright, so it is 35 km per hour. If I read the sentence again, Doji is driving his car on the express highway and the speedometer is reading 35 km per hour. Now you can see so many words here, but in physics, this is the most important, 35 km per hour. So what does this 35 km per hour mean? It means that if you break this down, fragment it, then this can be read as 35 km divided by 1 hour. And we know that 35 km is actually the measurement of distance covered, and 1 hour is the measurement of time taken. So now what happens to our formula is it has broken down into distance covered divided by time taken, and this mathematically is known as speed. So what is speed? Speed is distance covered divided by time taken. Now as you can see here, distance can be measured in kilometer, time can be measured in hour. So what happens to this is it becomes kilometer per hour. If you measure the distance in meter and time in second, then it becomes meter per second. So as you can see here, I've listed down 2 units for speed. One is kilometer per hour and the next one is meter per second. But there's one unit which is called as SI unit. So can you guess which is the SI unit of speed? Is it this or is it this? Alright, so SI unit for speed is meter per second. Please keep this in mind. The SI unit for speed is meter per second. So in a nutshell, if we see what is speed, then speed gives us idea on how slow or fast a body is moving. Next, speed has distance traveled, like you have seen in the formula. Speed also has time taken. The SI unit for speed is meter per second, and the fifth one, which is quite important, is speed is a scalar quantity. I'm sure you have learned what is scalar quantity and vector quantity. So if you have forgotten, scalar quantity means it shows only magnitude and no direction. So the next concept is velocity, and for that we're going to read this sentence, and like I said before, I want you all to find out the most important. And as a hint, let me tell you, there are 2 important points. So can you please read the sentence? So as you can see here, Doji is driving his car on the express highway and the speedometer is reading 35 km per hour. Now do you see that this is the extra sentence? He is traveling to Paro. So can you guess? There are 2 important points here. Which one do you think these 2 important points are? Okay. Yes, it is 35 kilometer per hour and it is Paro. So, if I may write it here, 35 kilometer per hour, we have seen already that this is the speed. And Paro here, we know that Paro is west of Thimphu. What do you notice here? West, which means it is showing direction. In other words, if you have speed and direction, this is called as velocity. So velocity is speed with direction. Again, if you want to write down mathematically, then velocity, because it has direction here, speed with direction becomes a vector quantity. So it is displacement over time taken. So this is the mathematical expression for velocity. Displacement taken, displacement covered by time taken. Now, if you measure the displacement in kilometer again and time taken in hour, then the unit becomes kilometer per hour. Likewise, if you measure the displacement in meter and the time taken in second, then the unit becomes meter per second. And can you guess what is the SI unit for velocity? Yes, SI unit for velocity is meter per second. So do you notice here that speed and velocity have the same SI unit, which is meter per second. So in a nutshell, velocity gives us idea on how slow or fast a body is moving. It has displacement traveled. It has time taken. The SI unit is meter per second. And finally, it is a vector quantity. Vector quantity here means it shows both magnitude as well as direction. Magnitude as well as direction. That's why velocity is a vector quantity. Okay, so the third concept we're learning is acceleration. Now, usually acceleration is always associated with high speed, which is totally wrong. In fact, acceleration is actually finding the change in velocity. And if you look at the definition of acceleration, acceleration is defined as the rate of change of velocity. Now, if you look here, we saw that the definition for acceleration is the rate of change of velocity. This is a definition. Now you have to fragment down in form of formula. So how should you do that? Do you notice this word rate here? The word rate here means you're dividing it by time taken. Time taken. Rate means time taken. Now what are you dividing by time taken? You are dividing change of velocity. Change in velocity. So change in velocity divided by time taken is the mathematical expression of acceleration. So acceleration can be written down as A. Change in velocity means you're finding difference in velocity. And V is the final velocity minus U is the initial velocity, and that you divide by time. So V minus U is change in velocity, time is T. So this is the mathematical expression to find acceleration. A is equal to final velocity minus initial velocity divided by time. Now, I hope you know that the unit for velocity is meter per second and the unit for time is second. So if you take this second up, then this becomes meter per second square. So the SI unit for acceleration is meter per second square. If you think that you cannot say this properly, then you can also say meter per second. Okay, so now to understand better on the acceleration, let us take this example. As you can see here, a car is initially at position A, and the initial velocity of this car is 0 meter per second. The car is traveling to place B, and here the final velocity becomes 10 meter per second, and the time taken for this car to move from place A to B is 5 seconds. Now can you look at this example carefully and tell me whether there is acceleration or not? Let's find it out, right? So we know that the formula for acceleration is change in velocity by time taken, and in this example we have the value of u as 0 meter per second, v is 10 meter per second, and t is 5 seconds. So if you plug in the values and simplify it, so 10 meter per second divided by 5 seconds will yield the answer as 2. 10 divided by 5 is 2, and meter per second per second. So this is the acceleration. So see, when the body moves from one place to another place with change in the velocity, and if there is some time taken, then we can calculate acceleration. Okay, so the charm of learning physics is the numerical problem. Now usually students face difficulty in solving the numerical problem. Actually it's not like that. If you understand the question, numerical problems are fun to solve. Alright, so let's see here. Now let's look at this graph. See, I've plotted a graph. In the x-axis we have time measured in second. In the y-axis we have velocity measured in meter per second. So what is this graph called? This graph is called as velocity time graph. Okay, so let's look at the first question. Now, what is the velocity of this object at t is equal to 2 seconds and t is equal to 5 seconds? So let's look at the first one. T is 2 seconds. So x-axis shows t and 2 seconds is here. So if you follow this path, then this is where the graph is. So at t is equal to 2 seconds, if you go towards the left side, because that's where our velocity is, if you go here, then we notice that the velocity of this object at t is equal to 2 seconds is 20 meter per second. Next, at 5 seconds, this is 5 seconds, and if you go here, it corresponds to 0. So at 5 seconds, the body's velocity is 0 meter per second, which means that the body has stopped. Next question. Here we are calculating now. We will use the formula and calculate the acceleration between 0 second and 2 seconds. So for that, you should know at t is equal to 0 second here. At t is equal to 0 second, what is the velocity? Velocity is 20 meter per second. And at t is equal to 2 seconds, what is the velocity? The velocity is 20 meter per second. And what is the time taken from 0 to 2 seconds? It is 2 seconds. Now using the formula, if we plug in the values, see, we get the answer as 0 meter per second square. So what is 0 meter per second square? 0 here means there is no acceleration. And what is the condition for this? An acceleration will become 0 if the velocity does not change. And in the graph, this line shows 0 acceleration because the body is moving at constant velocity of 20 meter per second. Let's look at the next question. Here we are calculating the acceleration between 2 seconds and 5 seconds. So at 2 seconds, the velocity is 20 meter per second. And at 5 seconds, the velocity is 0 second. And how much time is taken from 2 to 5 second? It is 3 seconds. So if you plug in the values now, let us look at the acceleration. What do you notice here? It is negative 6.67 meter per second square. Now, if you compare these two values, what you notice here is, here there's a negative acceleration. So what does negative value mean? It means that now the body is coming to a halt. The body, a moving body is coming to a stop, a halt. Okay, that's why the value for acceleration is negative. And for negative acceleration, we have a term, and that is called as deceleration or retardation. So in these examples, you have seen three types of acceleration. In the previous one, you have seen that the value for acceleration is positive, right? So positive value of acceleration means that the body is changing the speed. The body is changing the velocity. When the value for acceleration is 0, it means that the body is moving with constant velocity. And if the value for acceleration is negative, it means that the body is coming to a stop. Now the last question we will do here is to calculate the distance covered by this moving body. The body started moving from this point and it stopped here. So we are finding how much distance this moving body has covered. Okay, for that, if you look at this graph, I've just replicated this graph here. Now to calculate the distance moved by the body, you should know the area under the graph. Area under the graph or area under the curve. So this is our curve. Now if you shade this portion, then the area under this curve will give you the distance traveled by the body. Now to do that, we need to identify what kind of shape is this. If you look at from 0 to 20 to this point, then we notice that this is a shape of trapezium. Okay, so how do you find distance? We will actually calculate the area of trapezium. Area of trapezium, because this shape is a trapezium, and the formula to calculate the area of trapezium is half times height times sum of parallel sides. Half times, we need to identify what is the height of the trapezium. So if you look at this shape here, this is the height of trapezium, and the height is equal to 20. Sum of parallel sides here means in trapezium there are two parallel sides. So the parallel sides are this one and this one. Okay, so from here till here in the graph showed 2 seconds. So 2 plus, then for this side from this point to this point is 5 seconds. So now if you simplify this, we have here half times 20 times 2 plus 5 will give you 7. If you further simplify this, 2 1 is 2, 2 10 is 20. So 10 times 7 is 70. Distance is measured in meter. So 70 meter is the distance covered by this moving object to move from this point to this point here. Okay, so before I start my next concept, I want you all to look at these pictures. So what do these pictures show? Yes, it shows skydiving. So have you ever tried skydiving? Although I haven't, but I feel like I should do once in my life. So let's see. All right, now this is my skydiver, and as the person falls down, there are 3 questions that will be taken care in this slide. So the first question is, what happens to the velocity of this person? What is the acceleration? And finally, what forces are involved when you skydive? And to answer these questions, we're going to see the stages of skydiving. Alright, so if you see in this slide, initially the time is 0 second and velocity is 0 meter per second. As the person falls down, so as you can see in this slide, we have just taken the snapshot at every interval. And do you notice here that velocity at every interval of time increases? So this shows that as the body falls down, as the skydiver jumps out of the plane, the velocity at every instant increases. That leads to acceleration. This is the acceleration at this stage. So at every stage, you see that as the velocity increases, the acceleration is positive. Now this is just an example that I've cited here, and in this example, within the time interval of 4 seconds, you notice that the velocity is increasing exponentially, which means that by the time the skydiver or the object lands on the ground, the velocity is going to be humongous. All right, and with that velocity, if the skydiver falls on the ground, just imagine the impact. The impact would be, we would have, have all our bones broken. So but that in practical usually doesn't happen. All right, now why does it not happen? You have seen in the movies, you have seen in the videos that the skydiver opens up his parachute and lands very comfortably on the ground. So why does that happen? Alright, so it is because of this. Now in the next segment, with increase in time, please notice the velocity. At this time, the velocity is 70 meter per second. Likewise, as you go down, velocity remains same. Okay, if we are to find the acceleration, then the acceleration is 0 meter per second square. Likewise, in the next stage also, if you find the acceleration, it is 0 meter per second square. All right, so what does this mean is, it means that now after certain height, the body falls down with constant velocity. Initially, the body was falling down with increasing velocity, but after certain level, the body falls down with constant velocity, and that constant velocity in physics is called as terminal velocity. So what is terminal velocity? Terminal velocity by definition is the maximum constant velocity acquired by a falling object. All right, now in the next slide, I want to explain to you why terminal velocity. Why after some stage the body acquires constant velocity. All right, so can you look at these pictures, the different stages? All right, so I've just taken 4 snapshots of this picture, and please notice the difference in this picture. What is different? In the first, you notice that there's just one arrow, but in the next diagram, you notice that there's another orange arrow popping above the body. All right, so these arrows show forces. The blue arrow which points down shows the force due to gravity. Gravity has the tendency to pull everything down. So likewise, this falling object is being pulled by the gravitational force. And the gravitational force remains constant for a particular object. Okay, that's why the arrow's length are same. But initially here, you do not notice any orange arrow popping up. Alright, and this orange arrow represents the drag force. Drag force is the resistive force offered by the air. When the body falls down, the body comes in contact with air, so that's the resistive force. Initially, you notice that the drag force experienced, the resistive force experienced by this object is smaller than the force due to gravity. So what do you notice is this force is greater. That's why the body is being pulled down with greater velocity. And as the body keeps falling down, the drag force increases. It goes on increases until a point where the drag force is equal to the force of gravity, which means the force that pulls the body up and the force that pulls the body down becomes equal. And here, if you find the net force, then the net force is equal to 0. So students, please remember that at this stage, when the two forces are equal, when the net force becomes 0, the body reaches a constant velocity called terminal velocity. Okay, students, now to understand the concepts better, I want you all to do one activity here. So I've given you the same graph, the velocity time graph, and some questions. There are 4 questions. The first question is, what is the maximum velocity reached by this moving body? Please use the graph to answer these questions. Number 2, at what time is the body coming to a halt? Next question, calculate the acceleration between 3 seconds and 7 seconds. And finally, calculate the total distance traveled by this moving body. So there are just 4 questions. Please do it. So in today's lesson, we have learned 4 very important concepts in physics. The first one is called speed, velocity, acceleration, and terminal velocity. And in this lesson, you have also seen how physics is related in our day-to-day life. And in our day-to-day life, we have also seen how these concepts are applicable. I hope you enjoyed listening to me as much as I enjoyed teaching to you all. Thank you very much.